then definitely you know the importance of modeling. But if we talk about some UG or PG student, then usually the people don't understand the importance of modeling. Because when we talk about that we need to analyze this problem, we need to decode this particular code, or we need to break down this problem into smaller steps, and then we will further build it from a bottom to top fashion. Means like in normal sort of a very basic problem in computer science is sorting problem. So in sorting, there is a kind of we have the merge sort. So in merge sort, we initially do that we divide a particular array into two different arrays, then two into four, and so on. And when we have single element at the bottom, then we further build the solution in a bottom to top fashion. So similar way, whenever we have some problem, if we can further break it down, then do it. Don't worry about that whether it will become too complex to manage all the subcomponents and all. No, because when you work at a complex problem, if you are directly trying to generate the solution, it's not possible. Now the point is how this thing is related to modeling. So modeling is a kind of when you are doing something on computer, then computer is a kind of, usually we define in loose terms that it's a electromechanical system. Electromechanical because functioning with the help of electronics, and we have the mechanical design. Now the point is that this electronic machine is quite capable of doing n number of things which we human can do but can't do efficiently. For example, handling large complex problems, we can solve 2 plus 2 very easily and effectively than a computer, because for 2 plus 2, even if you are supposed to write 2 lines of code, that will take some time, but your mind is too quick to do that. But for some of the problems, for example, just to print the 1,000 prime numbers, you can't do it quickly, but a computer can do it in a snap of fingers. So point is this only, that there are some problems in the real world which we human can deal with but can't deal efficiently. That's why, just to bring the efficiency into picture, we are supposed to get dependent onto some sort of systems like computers. Now, when we are talking about the modeling, then modeling usually talks about that whenever we are having some problem, can we convert this problem from real world to a computational world? So just to convert a problem from a real world into a computational world, means into a virtual world, we need some sorts of tools. That's why we have the mathematical tools, some sort of mathematical definitions, some kind of exams, etc., etc. Means different sorts of mathematical terms then will come into the picture. And depending on the type of problem, different sorts of mathematical solutions will also come. Now the point is, when we are bringing so many tools and techniques together, do we have the effective orchestration system? For that purpose only, we need modeling. The right sort of modeling always help you to decode your problem and to generate the solution in an efficient way. So that's why only modeling is not important. The right sort of modeling, which sort of analysis is important, because modeling comes at the practical part. But before that, you need to understand what is the nature of analysis that you are trying to perform. That's why we are supposed to bother about the kind of data that we are dealing with. Because, for example, I want to solve a problem. Understood? Fair enough. But this problem is related to what? This problem must be dealing with some sort of data. So you need to understand the data first. Unless you understand the data, you can't deal with the problem. Similarly, as I gave the example of sorting numbers. So we have the normal sort of numbers, but how many numbers you are having? And depending on the number, means depending on the count of n, the complexity of a particular sorting algorithm is supposed to vary. So you can't apply any algorithm. That's why when a problem becomes large enough, then this role of complexity comes into the picture, which we usually talk about in terms of space complexity and time complexity. Bothering about the space complexity is not an issue, because nowadays we have a lot of hardwares, a lot of free spaces. Means even if we talk about 20-25 years back, at that time 1.44 MB pen drive, sorry, not pen drive, floppy drive was supposed to come in 10 rupees. But nowadays, if we go to market, even 16 GB pen drive is easily available in 300-400 rupees. So you can see that how drastically the space has gone, means space prices have gone down. So that's why we are not bothered about the space particularly, we are bothered about time. Because with advancement in electronics and with advancement in algorithms, still we are far behind than our expectation and requirement, because there is no real hard timeline which we want to touch. We want to be ultra absolutely real time. And that's why being actually real time is the target, but being actually real time is quite hard to achieve. That's why we have the real time systems. So coming to the specific problem and the discussion of today, I'll leave this discussion behind. This was just the related discussion that I was trying to build a sort of platform so that you could get to know some sort of understanding of the data analysis, why we are dealing with the data, why it is important, why computers are important, and why we are doing analysis with the help of computers only. So some of the questions are having simple answers, some are having moderate sort of. So slowly, hopefully I could do justice with the topic. And if I am unable to do the kind of justice with your questions, please let me know so that I could improve in some way further. You can ask questions whenever you have any sort of issue. It's not like this that you are supposed to wait till end. So we are starting with your permission.
Okay, sir.
Sir, 1 minute, I'm sharing my
Right.
PPT. My computer screen is visible, sir.
Yes, sir. Yes, sir. Your screen is visible.
Presentation.
Yes, sir. Yes, sir. Now you can make it full screen. So
It's fine.
yes, sir. Yeah, yes, sir. It's okay.
Okay, sir. So data analysis word looks something like this. Means n number of graphs, charts, discussions, progress, and like of these sort of things we usually see in the word. And then the relative success, failure, start of a particular trend, and all these sort of things. Usually these sort of things are quite popular in kind of meeting rooms, discussion boards, and most of the times we discuss these in companies and all, and MBA people usually deal with this. So ultimately, what is analysis and analytics? So we are going to start this thing with the very basic question, that is analysis versus analytics. So I hope that most of you understand this difference, but still if you are not familiar with, the difference is very simple, that both are depending on some sort of information, because ultimately data is important. If data is not there, then you can't perform any sort of analysis or analytics. So data is the fundamental requirement, which is quite common in both the things. But the only difference, there is a slight difference, that analysis is a kind of broader sort of concept, and when we do the analytics, then it becomes quite specific. Let me give you a kind of analysis. For example, if we talk about the social media, then in social media we have n number of data, means n types of data. A normal person, a teenager is also there, a old age person is also there, and even nowadays people have started to make the accounts of newborn babies, infants. So the point is that every sort of data is available over there, and that particular data might be divided into different sorts of forms. Means a general sort of analysis you can do, for example, male female analysis, very general, but it is not sort of analytics. Analytics is a kind of more specific word, more kind of technical word, you can say, that when we use some sort of specialized tools and techniques to perform analysis, then it becomes a kind of analytics. So there is no specific hard and fast difference, and that's why it's just a difference of words only. Ultimately, both are depending on data, and both having a common sort of motive to provide some sort of useful insights which is required for your particular need. Now, when we are dealing with analysis and analytics, one common thing is that we have understood both are depending on data, but still there must be some concrete differences. Yes, there are. So here you can see that comparing analysis and analytics, on the left hand side we have the analysis points, and on the right we have with respect to analytics. Analysis is usually breaking down the data. Now when we are having the analysis, then we are having the breaking down of data with respect to analytics, because we are having the data which we are further breaking it down, not the general sort of predictions. We are trying to make the some specific sorts of concrete predictions. For example, as I gave you the example of social media. So suppose I want to know that general analysis is that how many boys, how many girls. Okay, then in that also you can put another analysis criteria sort of that how many below 18, how many above 18, like this. Okay, and in that if you want to take the mean or sort of mean median mode or some sort of analytical techniques you want to put in and you want to use some sort of statistical tools or techniques just to find some sorts of deep insights. For example, how many students of a particular class are present on social media having a particular interest in a particular kind of topic. For example, very common thing is that using general sort of analysis, you can't predict the mood or behavior of a person. But using analytics, it's quite easily possible. Because nowadays on social media or any of the kind of platform that we are using, we usually see that if you are, for example, right now Diwali sale or something must be coming on or going on. So if you find if 2-3 items and try to search some of the items in particular Amazon or Google means Amazon or Flipkart sort of sale, then similar sort of when you will open your Facebook, the related item description will automatically pop up in front of you, suggesting you that please buy this particular item. It has gone cheaper. So how the Facebook guys are supposed to get to know that you are interested in a particular type of item? Because your data analysis, or we can say more specifically that the data analytics is supposed to be happening behind the scene, which is taking your data only. And that's why so many data crawlers, web crawlers means the kind of tools or the techniques which are running behind the scene, which you are not aware of, but they are secretly or in a calm way, they are just keeping a record of your activities. They are just collecting your data, and based on that particular data collected from your system only, they are performing the sort of analysis, and then they are buying, they are selling it. And some of the companies which are interested in you, they are buying that particular data. So now why the question is that why we have shifted from analysis to analytics, why analysis was not sufficient, and the reason is big data. Because before big data, there was not a problem of managing data. What is big data? That data has got so bigger that it has become to even store the data. That's why you might be hearing of the things means if you know little bit about the computer networks, then most of the times the system admin of any computer networks try to remove the unnecessary files or the temporary files or the junk files from the network. And similarly we do with our laptop. For example, if your system has gone slow, it is not giving you right kind of speed, then what is the best way? Delete the temporary files, check your recycle bin, check what are the junk files you are having. Means the unnecessary sort of data, whatever is available, just remove it, because your disk might not be giving the kind of best performance to you. So analysis was good enough when there was no problem of big data, but now we have big data issue. So having data is not the issue. Every company has data about you, but they don't have the deep insights about you. They are not interested in your date of birth, in your phone number, in your name, etc. They are interested in your habits. And that's why they are interested in analytics. So here, one common difference is that when we have the sort of analytics, then analytics is future oriented. And analysis is normally past or the present focused. But when we have the analysis in our mind, then normally we focus on the general sort of things. But when we have the analytics, we focus on the specific kind of things. So that is the kind of difference. And obviously, when we are focusing on analytics, then we are focusing on the specific kind of things. So we need the advanced sort of things. But for analysis, any sort of general tools are good enough. Even you can do the analysis using Excel. And using Excel, actually, I should not say this because Excel is quite underestimated tool. You can do a lot of things using Excel, but we don't know how to do it. That's the sole point. But in most of the kind of languages, or we can say the libraries which are available, using them we can easily do it because there are ready-made libraries. And that's why the Python has got so popular. There is no other specific reason, because so huge library support is available over there for almost everything, especially for ML and AI. So that's why using Python or using the similar sort of programming language which is offering you the kind of support in terms of the analytics library, you can easily perform the analytics on any sort of data. So moving further, we have the question that we understood what is analysis and we have understood what is analytics. So analytics is just a kind of deep approach of analysis. But what is data analysis? So it is nothing. It is the same thing, but here we are applying the analysis or the analytics on a particular kind of data. So when you are applying something onto something, then you have to go through a particular process, because you never know that what is the size of data. For example, what is the main difference in ML and DL? The major difference is that ML can work on a small amount of data also. But for DL, to have the right kind of accuracy, you need a huge amount of data. And that's why big data and DL are kind of complementary to each other. Because in one aspect, it looks like that big data is a problem. But in another way, if you just change the perspective, then it's a kind of boon. Because of big data only, you are having the efficient models, which are running the kind of AI you are seeing nowadays around you. And everything is getting automated. So whatever automation you are seeing around you, that is happening because of AI. But how the AI is functioning? AI is depending on data, and that data is supposed to be in huge form. That's why big data is a boon. So when we are coming to the process, because we are not bothered about automation, we are bothered about analysis. So when we are talking about the analysis, so it involves a particular process, because data size matters. If the size is small, you will follow a different process. If the size is large, then you will follow a different process. For example, you must have heard of pre-processing. In AI, there is a popular important step that what is data pre-processing. Pre-processing is the kind of thing that you are trying to remove the outliers. Means the data which is not contributing majorly to the actual sole essence of the purpose. Additionally, some sort of data which is not right, which is accidentally got changed or something like that. So that's why pre-processing means doing a kind of initial processing, which is not the actual processing, but which helps to improve the accuracy of your system. That is pre-processing. Now, to do this pre-processing also, you need to have the data. So that's why the first step is collection. You can see over here in the PPT, they have named, means I have taken obviously this data from internet only. So that's why I'm mentioning that they have mentioned these steps: the collection, manipulation, examination of data for getting a deeper insight. That's our motive of data analysis. And this analytics is going to do the same sort of task. The only difference is our way of functioning would be more meaningful and more useful. Means we are going to have the deeper analysis. So that's why whenever we are supposed to deal with the analytics, we are going to deal with the business sort of decisions. Means when we need to take some sort of useful decision, some sort of critical decision, then we are bothered about analytics, not some sort of general analysis. And for that, we need this process of collection, manipulation, and examination. And this is not the whole process. This is very general process. As I told you that pre-processing step is not there. Manipulation means you are actually doing some processing or something, and then you are examining the data. But still, again, following the different models of data processing, you can have a number of processes. But as of now, it is a very general process for a layman, because though I have prepared this PPT, but I have taken the data from the internet only, from different sources. So that's why these steps I have put in this slide, because this is a kind of introductory slide for data analysis and analytics. So if somebody is not familiar with the process of data analysis analytics, he should not get overwhelmed by the process itself. Process should be loosely defined. Later on, if you get to know about some sort of right way to explore the field of data analysis and analytics, you will find that there are n number of processes using which you can do the data analysis or analytics. So moving further, we have another important topic, that is types. We have understood what is analysis, what is analytics, what's the difference, what is data analysis versus analytics. Now, how many different types are there? So post seeing the process, we get to know that there might be different types. So first is descriptive one. The name itself is quite sufficient to tell the motive, but still I am just firstly displaying all the types. Second one is diagnostic. And third one is quite popular, not quite, I should say very popular, even most popular, that is predictive. And fourth one is prescriptive. Now, what is the difference? I think from the names itself, it's quite evident that what is descriptive, what is diagnostic, predictive, or prescriptive. Predictive is most important. Importance means, again, it's a debatable, though people say. But as in democracy, we do say that people are supposed to choose a particular choice. Means they should do a particular choice, or they should choose a leader or someone. So majority is the kind of criteria of having a thought that yes, this is right and this is wrong. So similar way, if we choose out of these four options, then predictive analysis is the most important, because most of the people use predictive only. Now, why is it like that? Because most of the times, what you are interested in, just ask a question to yourself. Do you always do descriptive sort of things? Means do you always write something? Do you give some description to people or to yourself? Or do you try to diagnose people more? Or do you try to prescribe something to somebody? Or do you try to just predict something? Usually people enjoy predicting things. Means, for example, somebody is asking you that what is supposed to be the result in this year? What is supposed to be the answer of this particular question? What is supposed to be the kind of election result or something else? What is supposed to be the stock market price next day, next month? So these sort of things are quite predictive in nature. So that's why we are interested and we are fond of doing predictions. That's why predictive analysis is most important. Then we have others also, three, which have their own importance according to the domain specific need and the kind of experts we are having at our side in our team. So this is not the exact order that we should firstly understand descriptive, then diagnostic, then predictive, then prescriptive. You can enjoy these sort of analysis in any way, because all are quite free in terms of relations or the foundations from each other. Nobody is directly or indirectly is linked. Yes, linking you may define, and they are linked. We can't say that those are not linked, because before concluding this PPT, if I forget, please let me know. Remind me that I'm going to just show you or discuss a kind of flow among these sort of different sorts of analysis or analytics using a kind of case study. And that case study is quite popular, that is Corona. So in Corona time, this sort of analysis happened a lot. Means analysis, data analysis and analytics was one of the most important thing that we were doing in the time or in the age, because the age is still running. We are living in the Corona age still. So that's another thing. So discussing the first one, moving further, we have the first one, which is descriptive data analysis. So as the name itself says, that we are trying to describe something. So that's why it is the kind of backbone of reporting, you can see. And it is important to have it to do the right sort of business, business. We should not say intelligence, actually. They are saying to have the business intelligence, but ultimately we are not interested in sort of intelligence tool or intelligence. We are most bothered about the decisions, though the decisions are directly related to intelligence only. That's why we are bothered about intelligence. So in a better way, I should have put over here that it is impossible to have right decisions without descriptive analytics. Okay, so business intelligence is in indirectly we can point to the business intelligence. That's right also. So descriptive analytics are important, and two popular types are ad hoc reporting and the canned reporting. The ad hoc reporting, as the name itself is saying, ad hoc means for which you have not having the kind of preparation or something, means you have not set up something. Instantly you are doing something, that is ad hoc. For example, in computer networks, there is very popular type of network, ad hoc networks. So ad hoc networks means which are very easy to set up, means in almost real time you can design a network, you can set up a network. Like we have the Internet of Things. So internet is very big concept. If we just say a network of things, then it is quite easy, and it's a kind of ad hoc network. For example, you try to connect to 4-5 mobiles using some Bluetooth connection or USB or something. So ad hoc sort of networking you are doing among things, because these are not considered as the powerful computers. So that's why these are sort of things. Similarly, if you are having n number of sensors and those sensors are interacting with each other using any particular sort of gigahertz frequency or something like that. So like in mobiles, we have the 5 and 2.4, the most standard gigahertz. So using those sort of things, if you want to try to have a sort of particular analysis, it means networking and then analysis, then we can have, this is the ad hoc example. Now, ad hoc reporting means we are trying to describe something. We are trying to do the analysis on ad hoc basis. Then it is ad hoc reporting. Canned reports are just opposite to it. Means when you have some sort of past data with you. For example, a news reporter is there. He is trying to give a report on a particular match or something. Then at least he or she should have watched that particular match. Then only he can comment on that match. That yes, I have watched today's match of India-Pakistan for 3 hours. Then I am in a position to comment on the batting of a particular batsman. So that's the canned report example. But ad hoc report is not like that. Ad hoc report is very general analysis. For example, you just saw the sky and you today's, for example, take the today's weather example. You just saw the sky and you just predicted, yes, a bit humidity is there in air, and air is also blowing hard, so most probably it is supposed to get rain or something like that. Because if you go to village side or something, then most of the predictions, most of the analysis are done like this only. Means they don't have any sophisticated tools or techniques. Just on ad hoc sense, they just do some sort of prediction, they do some sort of analysis, and that's ad hoc sensing. So moving further, we have the second type, and which is diagnostic. Diagnostic is related to diagnosis, and diagnosis term is quite popularly used in medical field. So when we have this diagnostic data analysis, we are bothered about examining the data. Because if we don't examine data, like a doctor or a nurse is supposed to do some sort of diagnosis. So they are supposed to examine the patient. But here we don't have the patient, our patient is data. So that's why we are doing the examination of data, and then we are trying to find some sort of relationship. Means this is the cause, and that's why this happened. This is the reason that this is supposed to happen. Like this, something like that. So cause and effect sort of relationship we need to find, that this is the thing, that's why this is happening, or this is the thing, so this may happen, or something like that. So we are interested in discovering some sorts of patterns. We are interested in discovering some sort of issues, and then we are going to raise some alerts. Because if you have found something useful and you are not telling others, then what's the point of finding out? So similarly, if you have some sort of pattern in your data, just inform to the management body that you have found a particular pattern, and based on it, they can take a particular kind of decision to foolproof the plan of future preparations or something like that. So the example, for example, a simple alert system they have given over here, alert about the lower amount of staff hours, which could result in a decrease in the closed deals. Obviously, but other than this, n number of other use cases might be there. For example, you have found recently one movie also came on corona vaccine. So similarly, they found the pattern. Indian scientists found the pattern, and immediately they disclosed to the government that we are trying to start the trials. We need the permission. That's why the immediate source of permission or decreasing the time limit, they were given the permissions, so that the effectively they can do some sort of analysis immediately. That was not the effective, I should not say effective, because usually the time limits to give permission for the trials or the actual production of the vaccine or something are supposed to be quite large, but due to the emergency of the situation. So sometimes a diagnostic might not be the actual diagnosis, because time is not permitting you. For example, for real-time data, for real-time systems, if you want to make the quick analysis, but that analysis is supposed to take some time, but you are not bothered about the actual testing or something, because you are having more cost in terms of running out of time. So that's why different purpose, different use cases, different sorts of analysis, and even the pseudo types of analysis, because the corona vaccine kind of thing, that was not the actual diagnostic analysis, that was a pseudo diagnostic. Then we have the predictive data analysis. Predictive, as I told you, that it is most common. And why it is most common? Because we are interested in predictions. Then this category can be broken down further into predictive modeling and statistical modeling. But don't think that these two are kind of different things, kind of complementary to each other, because without having the right sorts of statistical modeling, you can't do the predictive modeling. That's why having the right sorts of statistical tools or the modeling, you can do the predictive modeling. And it's true for many of different types of analysis or the modeling. Further, we have the last one, which is prescriptive. This is a bit interesting and not very popularly known to people, because prescriptions are supposed to be given by some sort of authorized people. And when we talk about the advice, then advice is very common. Everybody is giving you, but we don't want advice from everyone. We want some sort of authentic advice. We want the authentic analysis. That's why prescriptive data analytics is important, but you can't do it alone. You need some sort of tools and techniques which give you the kind of assurance that yes, what you are getting is supposed to be right. And that's why the role of AI and big data come into picture. I have already told you that what is the relation of AI and big data. Without big data, AI is nothing. If you don't have the data, then you can't make the predictions. Though you can make predictions without big data using nominal amount of data, but the accuracy is a concern. So that's why using ML algorithms, you can show that yes, these are good enough algorithms, but still ML algorithms are not supposed to use in real life. That's why ML is quite old, but still most of the automation that we are having in time, that is because of the actual latest AI developments kind of DL, and which are heavily dependent on big data. So here, what we are trying to do, we are trying to predict the outcomes. Ultimately, motive is same. But the only difference is those predictions, those actions are prescribed by somebody. And that somebody is AI. So that's why AI is giving you some sorts of prescriptions, and using that thing, we can further go for the optimization or testing or something sort of things. That's why, for example, what is the most kind of envisioned sort of things in computer science? That is optimization. Means we are always trying to optimize time. And not in computer science, even every field is looking for optimization only. But there is there are very less chances to optimize a thing after a particular threshold. That's why you need sophisticated tools, sophisticated techniques like AI and big data to optimize further. For example, as I gave you that if you want to add two numbers, very easy. But when you want to add the 1,000 prime numbers, first 1,000 prime numbers, it's not easy for you. That is also very trivial example, because using AI and big data, we are looking for at much more complex problems. Hopefully you guys know better, because we are living in an era of AI. So everything is getting automated around us. Then coming to the questions of ML, prescriptive analysis can help you to answer some of the questions. What if we tried this? This what if is very interesting, because earlier we were also supposed to think like this. Suppose I could have chosen this particular subject, what would have been my result? If I would have married this boy or girl, then I would have been in much better relationship nowadays. So this sort of things we do on daily basis. But the difference is, in real life, to do this thing on heavy data, we need some sort of computation power. That's why the ML and AI sort of things come into picture. Now, when we have learned about all these four different types, in short, the summary is this, that we have four different types. The descriptive analytics is concerned about the happening of a particular thing. Means what is happening, what has already happened, or something like this. You are trying to deal with that, and then you are trying to tell that particular thing to a particular machine. Okay, so that particular machine, that means if you are telling, you are doing analysis at your side, and if the machine is telling, that is doing the analytics. Okay, then the diagnostic. In diagnostic, why did it happen? So you want to find, you are trying to find the cause and effect relationship. Then predictive means what is supposed to happen in next 5 minutes, 10 minutes, 15 minutes, and so on. Then prescriptive means what is the first course of action to take. Suppose this happened, then what is supposed to happen? So let's take here itself the example of Corona. First one, we were in the descriptive stage. Okay, we were describing that what is Corona. because initially people never had the understanding that what is this means a disease. Many people were not even ready to accept it that it's a disease. Many people, even including many politicians, they were doing sort of illogical statements despite being on responsible positions that it is nothing like this, it is this vaccine, it is not reliable, etc., etc. Why these sort of things happen? Because we don't have the right sort of knowledge of a particular problem. That's why we need some sort of descriptive analysis so that somebody could tell you that yes, this is a dangerous thing, and why it is dangerous, let me tell you the reasons. So you are doing the proper descriptive analytics. Then we have the diagnostic analysis. Now you got to know that problem is dangerous. You have a particular disease, but you don't know the solution. To find the solution, you need some sort of diagnosis. That's why you need to find the cause and effect relationship. Why did it happen? Why my neighbor fell down suddenly? He was just okay 2 days before. Similar sort of things means you need to backtrack. Reverse engineering you are supposed to happen. Then predictive analytics. You got to know what is problem. You got to know why it happened. And now what is supposed to happen in future. My neighbor suffered, my relatives suffered, my parents suffered. Am I the next one? So predictive analytics was always happening, always, every second predictive analytics was happening. Then prescriptive analytics. Prescriptive analytics talks about the prescriptions. You got to know what is the problem. You got to know what is the cause and effect relationship. You got to know that I may be the next one or anybody can be the next one. So we should follow some sort of prescriptions. That's why what are the actions? Wash hands properly, have the face mask, keep the distance. These were the sort of things. So all these things which we were doing during Corona time were very well explaining the sort of analytics that we do in real life. So hope you understand the basics. Now the question comes that when we have understood the need of data analysis, but still the question is why? Means, okay, till now, because something got completed, something is over. For example, Corona, it's almost over for many of the people because we have already had 2 doses plus booster dose, etc. Now we are free. But when the next problem will come, will you be ready for that? So that's why advanced analysis or analytics is important, because we are living in a constantly changing world. Today it's Corona, next day it will be something else. Then it's always hard to predict what is supposed to happen. Additionally, suppose something happened, what will be your next target? What will be your next move to handle that particular situation? You never know. That's why we need to always have some sorts of prediction of our next course of action or something. Then, though you are not having any problem, it doesn't mean that you are not supposed to have the analysis. Whatever you are having in current world, is it optimized? If it is not, don't you want to optimize it further? If you want it, then who will do it? Only then proper sort of analysis will do it. So that's why even to just improve your current situation, your current goals, you are supposed to do the better analysis. That's why analysis is a continuous process. Further, and most important, that we do need analysis. We do need data analysis, but how to do it? Obviously, some sort of tool must be there. That tool might be a software tool or a hardware tool. Means we are not interested in tool, we are interested in design. And that's why creative designing is a sort of very important thing. How do you design a solution? So a solution from analysis point of view must be predictive. Obviously, as I told you, that it should give you some sorts of right predictions, because we are interested in predictions most. Secondly, it must be intuitive, means based on intuition, it should work. Based on some sort of past learning, it should have some sort of recognizance, means some sort of ability to take decisions. It should be intuitive. Additionally, it should be self-learning. It's not enough that it had some past knowledge and based on that it is working. It should have the continuous ability to learn from the environment. And fourth one is adaptive. There is a very fine difference between self-learning and being adaptive. Self-learning, that you are learning from the people, you are learning from the atmosphere continuously. But are you adaptive? For example, you can work in AC room. You are supposed to have new courses, new semesters, new students, everything you are dealing with effectively. But all of a sudden, your cabin is changed, and you are supposed to get thrown in a kind of dust-based room. Means that there is no proper ventilation, AC, etc., etc. You are the same person. You have the same capabilities of being predictive, of being intuitive, of being self-learning guy, but still you are not adaptive to the environment. That's why you are not able to function. So adaptiveness is most important, because a solution should always work. It is not like this that in one environment it is working fine. You can't proclaim you are the best person, you are the best resource person, it is the best solution based on one environment. And the most common example is that in research we do have lab experiments. Your lab experiments, will it work in real life? Then how it is supposed to be adaptive? How it is supposed to be useful? So whatever things, most of the things, the biggest drawbacks of our research, even the PhD research, everything is that we most of the times produce the results which are lab experiment based results. And that's why those are not adaptive. Moving further, we have everything now in our head. But the final question is, in my present time, who am I? Am I a data scientist? Am I a data engineer? Or am I a data analyst? Because on daily basis, we hear these terms. We hear about these sort of gossips, means kind of discussions in academic corridors or anywhere. But we are highly confused. Even most of the learned people who are not the actual data guys or computer guys, they don't understand the things. The reason is quite simple, because these things are highly mingled, highly overlapped. But still, there is a fine boundary which this particular figure is supposed to draw. So you can see that a data scientist is particularly supposed to deal with data. So he uses some sort of statistics or the machine learning techniques to make the predictions or answer some of the related questions. The kind of things that you can have some sort of in your hand are programming, some sort of statistical knowledge, mathematical tools, etc. What is a data engineer? An engineer is supposed to apply the engineered algorithms, means some sort of latest sort of things to analyze some hidden patterns or something like that. So that's why you are supposed to optimize the systems. You are supposed to analyze the things at their best possible way. Now, to do this thing, you have the similar sort of tools in your head, the statistics, programming, etc. But you should have the right sort of data also. That's why big data and the cloud is giving you the power to process data. So that becomes the obvious need. Then third one is the data analyst. Data analyst is supposed to take the data and communicate the results to the decision makers. As simple as that. Engineer is trying to figure out the patterns, and the analyst is then supposed to figure out the impact of those patterns onto the market results. So these are different sorts of people. You can say that the data scientists work usually in labs. The data engineers work normally at the high level, means at sophisticated distant places like warehouses, the kind of workstation, means having big workstations and like data centers and all. Those are data engineers. And the people who are in boardrooms, who are presenting you some sort of analytics, who are giving the presentations, who are the kind of media persons from company side, the spokesperson. Those are the kind of analysts. So you have the meetings, the communication knowledge, business knowledge. That is the obvious thing. So that is the basic difference. Hope this presentation must have given you some sort of insight. I know most of the things are basic, but still, that was from my side. Hope you liked it. Thanks for being a supportive audience. I'm open for your questions. Thank you so much.
Thank you very much, sir. So everyone, you have any question? So I think then you don't have any question. Okay, thank you very much, sir. And also I want to inform everyone one more thing. that Rohit sir, he's organizing a workshop, 2-day workshop in December 1 and 2. So maybe sir, you can also inform that one, so that
Yes.
they.
Okay.
Uh-huh.
And actually, December 1st and 2nd, we are planning a workshop. That workshop is targeting the blockchain assisted secure cyber physical system. I don't know that how many of the guys from the audience do understand cyber physical system. Cyber physical system is nothing means a kind of system which is having two layers, a cyber and a physical layer. Physical layers means the kind of sensing, the actuators, or the sort of physical things. All the physical things are coming at the physical layer, and all the cyber related activities, cloud computation, analysis, these sort of things are supposed to come at the cyber layer. So when we have these two layers together working as a form, in a form like it is a complete system, means there is a tight close relationship between these two layers, then it becomes a kind of cyber physical system. So cyber physical system is supposed to deal with this only. Let me just open the brochure if I have it. Yeah, here it is. Taking bit time. Yeah, hope it is visible to you.
Yes sir, yes sir.
So it is the brochure where we are planning for a blockchain assisted secure cyber physical system. The focus is to make the cyber physical system secure using blockchain, because blockchain is one of the latest technology which is supposed to change the way we usually practice doing the kind of exchanges in our banking systems or somewhere else in any particular fintech domain. Then we have some of our speakers from IIT Madras, IIIT Kanchipuram, etc. And we have some industry people also. Then we have two of we are from SNU Chennai only. So we are going to deal with some of the related topics, like we are going to talk on the blockchain and Hedera. Then these Hedera, Ethereum, ledgers, NFTs, all these are blockchain key terms. So if you are familiar with blockchain, then only you are supposed to have some sort of meaning. Otherwise, it's just a simple introduction with respect to the blockchain and how the blockchain is useful in the domain of CPS. Here, this is supposed to be going to be a one interesting talk, which is the building safer plates. This particular topic is going to deal with that how we can do the integration of IoT and blockchain to deliver you the secure and the safe food chains. Food chains is usually supposed to deal with the supply chains. Hope you understand the meaning of supply chain. For example, something is getting delivered from Amazon to your doorstep. It is coming through a supply of chain. Sorry, chain of supplies. That's why it is a supply chain. So similar way, any sort of supply chain which is delivering something, which is processing something, that is a part of supply chain. So another important thing is that localization in the precision system. It is going to talk about that there is some sort of real system or some precision system. In that, how to do the localization. Localization, if you know about the robotics, then it is very important thing. There is a term SLAM, simultaneous localization and mapping. For example, how a robot moves. A robot doesn't have the real vision, but based on the camera and all, it tries to localize the environment. That's why firstly it creates a map. That's why the term is simultaneous localization and mapping. It tried to create a map using cameras, and then it tries to localize the environment. Means this particular object is this much far from me, and that's why I should not touch it, or should I touch it, how frequently should I touch it to make it enable or something like that. All the cognitive sort of powers are coming from that side only. So that's all. If you are interested, you can attend it. It's that's all from my side. Thank you, sir.
Okay, thank you very much sir, thank you very much sir.
Thank you, sir.
So if you guys have any queries, so you can leave me the questions, or if you are coming to the office to SNU, then maybe you can directly meet to Rohit sir. He's also sitting just in the same room as me, like 309 in academic block 1. So I think it's okay. Thank you, Rohit sir, again. Okay.
Welcome, sir.
Okay, sir.
Thanks all.
Then,
Thanks.
okay. Okay, everyone, and I'll send the like I have recorded this session, so I'll send this session to you, to all of you. Okay, sir. Thank you, sir. Thank you very much, sir.